to another day of CS 202 video 12. I hope you are all doing good today. Go ahead and move this out of the way so it doesn't detract from the image. Alright, hello. Cool. Let me go ahead and show you what we're going to be doing today. Okay, there we go. So today we are going to be talking all about templates, and I don't expect this to take us the full class period. So for the remainder of the time, we're going to be introducing a very important concept in programming known as recursion. And that will definitely be everything for today. I'm pretty sure we will continue talking about recursion tomorrow as well. So let us go ahead and get started. If you recall last time, we were basically introducing templates, and then we ran into an interesting problem with two's complement in a way with overflow of that character. So let me go ahead and just go from there. There we go. Okay, and then let me go ahead and pull up YouTube. Okay, there we go. So looking at this piece of code, we were just talking about the idea that we have a bunch of add functions that created, right? Like we have an add for integers, an add for characters, an add for doubles, I think. And then it's essentially all of them the same code because they're all just a plus b, basically adding the two parameters together, or at least not adding, but basically putting a line of code that says a plus b. And that may not necessarily mean adding in all senses, because for strings, it actually means concatenation. But the point is that that function, all it does is it basically puts the first parameter as one operand, the second parameter as the other operand, and in between it puts the plus operator, whatever it means in that context. And you know, it sucks that we have to copy and paste the same code for different parameters and for different types, you know, because we can't just make a coverall, because otherwise then coercion will change the type of parameters, and it might not even work for some of them, like the string one. And so templates allow you to sort of create a, as the name implies, template, which another synonym for that could be a sort of a generic class. In fact, that's actually one of the accepted names for templates, or a generic function as well. And in that sense, you are able to sort of create a function that has a parameter that is of a generic type, which is basically saying it's some type that I'm not gonna tell you yet, and you will only know the type once you see the function call itself to resolve that type. And it can be very, very useful in order to be able to write all of these functions that do the same thing, but take in different types for each of one. And so that's exactly what we did. I know we kind of focused on the issue that we had at hand with the adding, but you know, really this actually was once we realized why we had that negative. I mean, this was working as intended with that interesting side effect, and that is that we write the keyword template, and then we put the less than and greater than signs, as you see here, and in between we put the word class, although I believe you can also use another word for this in here, another keyword in C++ as well. What's the other one you can use? There is another word. Anybody know it in chat? Trying to remember. That basically does the same thing as writing the word class there. I think it's like type def. No, that's something else. Shark type test is something else. Google online. Maybe we'll find something that way. Template function example. Just to see somebody else might use the other one. Template class. It's other than class. Type name. There we go. Type name. Yes. Okay. Type name. So it's okay if you guys don't know it. I mean, you've probably seen type for the first time today. So another thing that you can use for creating a template function instead of class there is the keyword type name. So yes, type name. Yeah. I basically just Googled function templates references, which is probably what you were looking at as well, which is that one. So yeah, there is a difference between them. Like I remember reading into detail last time I did 202, and found out that there was actually a difference. But for all intents and purposes, it's the same thing. Like there's the difference is so peculiar that for like 99.999% of the cases you won't notice it. But there is some difference. Like I think that's as far as I went into researching that, because somebody's question was like, what's the difference between them? And I was like, I don't think there is, but let me research on it. And then I went and I saw that there was some difference on the special scenario. I don't remember at this point, that sorry. But you can go ahead and Google the difference of the usage, and you'll find some Stack Overflow example that shows the difference. But you know, outside of that weird scenario, they're gonna be acting the same way. And so the way that you write templates, again, we'll use an example now. Let's say we're gonna do the same thing that we were doing before, but this time we're gonna do it for a subtraction, okay? And so in that case, we can make the type be returned as a T. Okay, let's back up a second. What we're saying here is that we're gonna have some data type, and that data type is not going to be defined yet. We're just gonna have a substitute for the data type in the form of the character or identifier T, okay? And so now, I mean, this could be more than one character. So this could be like, you know, we'll call it a to-do type, you know, because it's kind of like to be added later, or to be added later, to be announced. How about that? TBA, okay? And so it basically have a data type that we are going to fill in, but not yet. And so we can use that within our function in multiple places, including the return type here. So we can make it return this TBA type. We can also have parameters. So in this case, we're doing subtraction. So we're going to do subtraction. And then we could have one or more of the same parameter. So like we could say TBA for the parameter, TBA for the second parameter. These can also be pointers as well. Yeah, they could be pointers. I guess I'll show you later an example with pointers. You could also have more than one type as well. That if you want to have more than one templated type, in case you don't want all parameters to be of the same type, you could do that too. But here, for now, with subtraction, let's just stick to this. So in this case, let's just go ahead and do this in a single line of code. A minus B. Like that. I could declare any variable locally, you know, like this, and then dynamically allocate it even, like that. I think that's fair. Yeah, I think that'll work. There's no reason why I'm doing this. It's just to show you that it's possible to do. I'm not gonna go delete it afterwards. Should work. Let's go ahead and test that real fast. Yeah. Okay. Worked. Okay. So yeah, that would be how to create a function template. Again, we did that before, but this time I'm using the type name keyword instead of class. Let me show you an example where you can go ahead and do multiple templated parameters. And by the way, you do want the template to only be really applied in the parameters or in the return type. If it's in neither one of those, so like if you were just having it as part of the code in here, there really wouldn't be a usage of it. Because here's the thing. No matter how you set up these sort of generic functions and later on generic classes, the compiler needs to know at compile time what this will get resolved to. This is not something that you can defer to runtime. This is all happening at compile time. And what I mean by that is that when I do my function calls, the compiler knows exactly what function calls I might have. Now, I might have an if statement where I say, like, if A is greater than B, call this function with these parameters. If B is less than A, or if B is equal to A, call these functions with these parameters. And that's okay, because what the compiler will do is it's going to check all of them in both cases. And so because of that, it will know exactly what the type, the real type, the one that actually is going to be used, is going to be. And so it can actually, what it does is it's actually going to basically write out the proper version of the functions with the types that you pass in. So like here, these two are cars, and so it's going to create a function called int r add with car parameters here, so that it can run that. And then it's going to create a function with integers to run that, and a function with floats potentially to run with that, and if a function with strings to run that, and so on. And so it's going to make sure of a couple of things when it does that. First of all, is the code valid, or would it be valid had a function being written that way? If a function, if I wrote a function called int add that had two car parameters, and I did car a plus b, is that valid code in C++ had it been written? And the answer would be yes. But however, we will see that with the subtraction, that may not always be the case, because let's try and do that with a string. Unless you've done the string assignment and you did your own weird string class, the regular string class, there's no such thing as subtracting strings. It makes no sense whatsoever. So here's an example where, it's not always going to be valid code. And so if it isn't, then you're going to get a complaint, just like you would if you were writing a function that actually used string as parameters here and then try to subtract those strings. So let's go ahead and do that next. For now, let's go ahead and switch your tadd to, and we can leave it like that actually. Yeah, why not? Leave it like that. Let's just go ahead and not subtract it here. So let's try do the subtracting. So it's called subtract, or subtraction, I guess. Yeah, subtraction. And it takes two of the same type. Now that's the other thing. They have to be the same type. Otherwise, you're gonna, I don't even know if it will try to coerce. So let's try and see if it'll coerce by having one be an integer and one be a double. And let's see what happens if it tells me that there's no matching thing, or if it does some sort of coercion. So it says no matching function call to subtraction double. Yeah, so whereas if I had a function that basically took two doubles or two integers, if I had one of those two, it would be okay. You can think of this as a scenario where I have all possibilities. I have two with doubles, two with integers, two with floats, two with strings, two with cars, two with whatever. Because of that, this becomes an ambiguous call, because it's like, I don't know which one you want to go towards here. And so the template argument deduction substitution failed, because it can't figure out, like, should I make them doubles or should I make them integers? Like, it's the same distance to make them both doubles as it is to make them both integers, right? So that, if you wanted to have something to be a different type, then you could write this function, but instead create two templates by calling them, let's just say, type A and then type B. I believe that is the syntax. We might need the word class again here. Yeah, okay, there we go. So now, let's say that we can use the second parameter here as, as type B. And then this is type A. And then, so now, there is probably a big delay if you set that before you saw me type this. Try refreshing, might help. But yeah, so in this scenario, you know, this could be okay because it can associate this to be an integer and this to be a double or different types, okay? That doesn't mean if this is gonna work okay or not, we'll see. I mean, this will compile as long as I got the syntax stuff, right? And I get rid of the ambiguous call there. Actually, I did get rid of it, so why is it complaining now? Oh, I see, because I still left the TBA here. So it should be a type. Which type do I want to return? I should say I want to return an integer, actually. Not even neither of them. Or no, let's do type A. Why not? Make it more flexible. There we go. Compiles just fine. This does run as it is so far, unless I have like memory leaks or something, whatever. But if I go ahead and want to make a couple of calls to this, let's go ahead and see what happens with the subtraction call. With the subtraction call, this should be calling here. Let's go ahead and put a cout statement so that we can see what's up. Let's actually use this. Actually, really nice code that we figured out last time. This whole type ID thing. It's pretty convenient. I actually didn't quite know how to do this before yesterday. I knew it like in Python and things like that, but I didn't know you could do. There was such a thing in C++. So that's pretty neat. So yeah, let's go ahead and put those in there like that, so that we can actually see the types of each of them. And here we go. Let's put an end line after the subtract as well. Okay, so we can see that it's a double and an integer, and while it doesn't really tell us the class name, we could probably add it in here. We'll just make it some single character. We'll call this one A, and then we'll hit this one. We'll make it B. And then we can call it add C. Well, I guess we'll do that one up here like this. Maybe we'll put a space like that. Okay, so we can see here that I guess A was not the best of examples to use for that. We'll call it sub 1, sub 2, and maybe add 1. Okay. So add 1, add 1, add 1, and sub 2. So you can see here that sub 2 is the one that is being called because it's of 2 different types, and that actually matches that. If you want to call the first one, then they would have to both be the same type. Whatever type they are, it would have to be that. So let us go ahead and try. And by the way, I've been using literal so far, but you could use variables as well. So yeah, let's go ahead and make them be 2 integers. Like that. Did I not save? Why didn't it make anything printed out? Subtraction 2 for cout. Oh, I put it after the return statement. My bad. Big mishap there. Okay. There we go. So now you can see it print out. So you can see that it's calling that version. But here's the issue with this, okay? Let's try to do this with the string. Because, I mean, there's no subtraction with strings unless you're doing your string class, right? You know, we'll say S1 for string 1, and then this for string 2, okay? So here we're going to get a compile error. Not a runtime error, but compile error, because again, this is all done at compile time, this type checking stuff. So in instantiation of the template, require from here invalid conversion from long int to const char. So basically, it does not like the subtraction. It's just confused as to what is happening, or which one it even is doing. I'm actually curious which one it's doing. It's doing the one with the same types, which makes sense because it's two strings. But the big error here is that there is no such operator that exists. There isn't an operator that exists that allows us to easily subtract strings, you know? And so because of that, this doesn't work. And how do we fix this potentially? Well, don't call it on the string. That's the easiest solution, I suppose. And if for some reason you actually intended this to be a thing, you can use operator overloading and then overload your strings, and then this will work again. So templates are great to save code, but they're not gonna, you know, do magic. You know, they are limited upon the operations that are allowed within C++. Now, the other ones were built in, so we had no issues. This one is not built in. Similarly, if I try to call this on two objects of two different classes, so like, say I'm gonna call this on an A and a B, and then I'm gonna make class A and class B be like random classes that I have. So we'll make them be like class A and then class B. Okay? And so now, if I go ahead and make objects of each of those classes, I don't have to make them. I can just get away with using one class, but whatever. Let's just make two objects of the same class. A2, how about that? A1 and A2. And then if I pass those in, I'm gonna get a similar error. If you scroll up high enough, you'll see it. This is probably complaining from the type ID thing, because there's probably no way of easily getting that. But no match for operator subtraction of the types. Oh, that's the other problem. It's when the subtraction returns a type, that type is of a class. And yet again, that is an issue. So here, let's get rid of that one for now, so we don't have that big error with the cout, which we could fix if we overload the extraction and insertion operators, so we can see in and see out into things. But still, we're getting another no match for operator less than sign. So basically, this is complaining that there is no built-in operator to do the subtraction between these two objects of classes A. And so if you wanted this to work in this version, then you'd have to overload class A to allow that. So basically, you would need to create a function in here. It's been a while since I did the operator overloading, but it would need something like and then it should both return an A as well, I think. And then you could do something like you know, subtraction and all. And I do believe, I think you're supposed to return the this pointer or the resulting object if you wait one. So yeah, let's just make a random answer and then just return that. So I think that's if I remember my operator overloading, it's kind of like that. Oh, but never mind. Not equals minus. We're overloading the minus one. So there we go. Now it works. Okay. So we have overloaded the subtraction operator for objects of type A. In this case, of course, they're not. All it's doing is couting something. But the point is that if you overload it, now it works all of a sudden, which is good. because they're now, even now, you know, it knows that when it actually creates that function and you're subtracting two objects, there is an operator that I can actually handle minusing them. As you can see here, I get sub1 on object of A and object of A. Why did I say 1A like that? I don't know. It's coming from the type ID thing that we put, I guess. I guess that's just part of the thing when you do it with a class. It puts a 1 in front of it, I don't know. But either way, at least it tells us that it's a class A. And then you can see here that this is being printed out because the subtraction operator is being called, and that's what's happening. So I suppose if we wanted to overload the, so that we could see out things properly, so that we could leave it like we had before like this. Because right now we're going to get that nasty error, because yet again, there is no such way to see out an object. It's not built in. So if we want to fix that, we would have to overload the extraction stream insertion operator, which if I remember correctly is something like OS stream, and then we have the parameter. What's the parameter of that? I think it's OS stream as well. Yep, OS stream out, and then something. I think we have to make it a friend function actually. I think we have to make it a friend function, and then pass in an object of A. So we'll make it a friend function. And then this we can do to say something like out. Obviously, if there was a member variable to this X, then we could access it here. But for now, we're just going to say it is sub. No one in mind actually. Return out. I think you gotta return out like that. It's been actually quite a while since I've tried to do this. Out should be initialized. It is initialized. It's past my reference. Oh, yeah. I forgot that. Yep, thank you. Well, big memes there. Okay, thank you. Yeah, you guys caught me on that. Yes. So there we go. Now that works. So there you go. There's a quick review of operator overloading for both you and me. So there we go. Now it works. So templates are great, but now you also found a kind of cool usage of operator overloading in addition to kind of, because when you learn operator overloading the first time, which would have been right before this actually, if we follow the proper schedule, then you would have been like, this is kind of, I mean, it's cool because we can write code in an easier way to understand, but at the same time, it's a lot of work for not much. But the reality is that one of the nicer reasons of knowing operator overloading is if you really want your templates to still work, you know, with such a short and clean syntax. I'm still not a fan of operator overloading in the first place. I don't really use it, but I suppose it can, I guess, come in useful when you're doing templates. So yeah, okay. So that is how function template works. It can get a little bit tricky to check whether something will run or not, but it's okay because if it doesn't run at compile time, it will not let you compile. And so that's kind of the nice thing about the templates is that you will know ahead of time if you screwed up. You know, it's not going to compile otherwise. So yeah. Does that make sense? Are there any questions about a templated function? Let me see if I can think of anything else to say. Let me look at the book and see. Nope, that's it. I mean, even in the book, they have like a page and a half on it. So, yeah. Template is a reserved keyword. It is allow you to write a single code segment for all set of related functions. So, yep. That's pretty much it. Class templates are the more interesting ones. And those will give you headaches. especially when you start doing like inheritance and things like that. So let's talk about those. So we've seen the first half of templates, which is function templates. The second half of that is going to be class templates. And so similarly to function templates, where you basically can fill them in at compile time with the types that you want to use, class templates is going to be sort of the same idea. So imagine that you have a class, and you don't have to imagine it, we're actually going to put it in here. Imagine you have your class A, and class A has a variable x, okay? But this variable x, you know, right now is an integer. But suppose that then you're writing another class, which we're going to call like A2, and in that one it's a double. And not just that, but in addition to having that, maybe it's actually a private variable. Well, we don't need to say that private there. So what we'll do is we'll just click here, and we're going to put a setter and getter for that. So maybe we have a get x that returns an integer because it's an integer, and basically this just returns x like that. Okay, we'll do this in one line because otherwise the code's going to get kind of big. And then we also have a setter. So for that, we simply have void set x, and that just basically sets x to whatever the parameter is. So int b or int parameter gets that. Okay. And because we have another class that's basically the same thing, then we want to basically copy paste like that, and then we just have to change this to say double. And also in the parameter to say double. And now all of a sudden they're like, this is so good. We also want one for floats, we want one for strings, one for cars. And you're like, oh my god, that's a lot of copying and pasting, and that's a lot of repetitive code that is hard to maintain, because later on, you know, they're going to be like, hey, we like this so much that can you make one that has 2 variables inside? And now you got to copy paste even more and more and more. And so class templates are going to also allow you to sort of make this variable be a generic type, so that it can be at compile time sort of filled in with the type that you want. And that's very powerful, actually. At first, it might not seem so, but it is. And so let me go ahead and give you the syntax for a function template. By the way, I'll write that one more time, the one for the class template, and then let me write one for the function template in here so you have it nice and handy. So template, class, t, and then you have your function. So like for example, t, foo, t, a, you know, and that could be an example of a function template. For the class template, and by the way, I guess I'll put in here class, or we said type name, I think, right? I already forgot because I don't use the other one. Type name, yeah, okay. So the other one is going to be the class template. And that one is going to be very similar, actually, in the sense that you're still going to put the word template in front of it. And you're still going to put in here the keyword class or type name. Put some identifier. Usually people like to use the word t or type. And then, but it can be any variable, as you saw. I use TVA and things like that. And then go ahead and do your class declaration here. So an example of that could be, come on. That less than sun looks weak. There we go. You could say class A, put your curly brackets so you don't forget. And in here, we are going to go ahead and put in a variable that is of that template type, the generic type. And so we're going to say T of A, like that. And that is it, at least for variables. For functions, it gets a little bit interesting. Not now, actually, for the, but if we kind of, you'll see. But let's say we have a function foo, and we want to have a parameter of that type. Actually, make it return that type too. So you could do something like T of G or something. I don't know. Whatever body is in there doesn't matter. Let's just leave it like that. Okay? So I don't know what we were trying to do with foo there. But yeah, there you go. And you can pass by reference, by the way. You don't always have to pass by value with templates. I've been doing that so far. In fact, I actually wanted to share with you something kind of cool, which is what I have up here, a little double ampersand. If you ever see a piece of code that is of this format, so forget about templates for a minute. If you have a piece of code, or you see a piece of code that says void foo, and then you have something like int ampersand a, and then there's some code that works with that one, you might be asking yourself, what the heck is this? Like 2 ampersands? Like, that's scary. Isn't that the logical and? And you are correct. In some scenarios, yes, that would be the logical and. It's a binary operator. And a single ampersand is address of operator and also signifying passing by reference. But in this scenario, it actually means something completely different. It means that this parameter is being passed as an rvalue. And what is an rvalue? Or about rvalue reference, sorry. An rvalue reference, to not get too hardcore into this, is you can think of that as kind of like a literal, or something that is not a variable, or basically that it doesn't have an address in main memory that is accessible to the programmer. Okay, so normally a variable is an address, and we know that because we can use the address of operators to figure out what the address is actually. But in the scenario where you have rvalue versus an lvalue, I suppose an lvalue would be one that does have an address. An rvalue does not have an address. An example of that could be something like a literal value, or something that is not allowed to be modified. Most of the good examples would be basically a literal, because even a const, I think, has a address, but it's just not allowed to be modified, so it's kind of special. But it might actually, I don't know, I have to double check if a const is actually considered an rvalue or not. But in it, we can test it. But my initial, my spidey senses tell me that it's not, But if you want to see how that actually works, we can do that really fast. Ignoring our little classes that we made right now, let's just triple check that this compiles. It does, okay. So if I write a function here called void foo, like I have it there, and I put in the int ampersand a like that, and then I do cout a, a non-modifiable lvalue. Okay, there you go. So that's it's not an rvalue then. Or expected comma or the dot before the ampersand token. This is only work with templates. Is that why it's complaining? Oh no! It's because it's C++11. This is a std equals C++11 thing. Yeah. So this whole R value L value magic is coming in C++11. So yeah. Otherwise it won't compile. But yeah, okay, so that makes sense, that what you're saying. So yeah, that a const would be a non-modifiable L value, because a const is an address in memory. We can see the address of this const by creating one. So int const a equals 5, and then I can go ahead and cout that address of a, like that. And I can even do some magic to actually modify a cons, although it creates undefined behavior technically, which means that it may or may not work in some systems. But yeah, it's an address like any other variable. So I guess it is correct in saying that it is a non-modifiable lvalue, whereas this demands it to be an rvalue. So if I try to call foo on something that is for sure a literal, like this, you know, this has no address in memory. There is no address for 5. It's just, I mean, don't get me wrong. When you compile, it does get turned into an address, and it does get stored somewhere in memory because it needs to be accessible. It's not just stored in the CPU somewhere. It's actually an address in memory that holds a 5 in it. However, that address is not accessible to the programmer to mess around with, and that's why it's an rvalue. So if I run this will compile, and this will run, and you expect to get a 5 there. So this is good to go. However, if I try to pass, I guess, let's do the A, since we said the internet has an lvalue. This will cause an error at compile time that says cannot bind const int to lvalue to int foo. Initializing argument of foo. So yeah, it cannot bind it on that. It also will not work on a regular variable. So if you have like int a or int b equals 45, it will give us similar error. Instead of constants, it was just going to say int there. So there you go. However, it will work if I am doing something like b plus 5, because that's also a expression that is basically equivalent of a literal, right? Because even though this is a variable, once we do the addition, the result of that is just a number. It's not an address location. And so you might ask yourself, what usage is this good for? It's good if you don't want the function to accept variables for some reason beyond the scope of this course, I suppose. But when you're doing templates, it can come in actually very useful as well, because you may only want templates that are sort of like literals per se versus like variables. Because I mean, you could do this. You could pass in here. Let's make bb a double, and then now I can pass in 5.4. You know, and now it's an addition of 2 doubles. And so if I do that, it works just fine. Although there is a coercion that is happening here. So here, let's switch this to be a double so that we can have the full accurate value. Now we can see 50.4, right? So, you know, you still want to have this work on other data types that as long as it's still a literal, but a better term for a literal is going to be this rvalue idea. That is something that is not accessible, but yeah, an address, okay? So just a little sidetrack there that I wrote it there because I was like, this is actually something that might be useful in case you ever run into it in code and you don't panic and you're like, why did they put 2 ampersands? They must have a typo in their code. And it's not even compiled in the first place, right? But that's because we were probably trying to compile it without the C++11 flag. So we'll play with this in a second, but let's go ahead and finish our class. In fact, we can say that we are only going to allow x to be set by something that is of a literal type or rvalue, okay? You can do that. That could be an interesting usage of that, actually. You know, just for fun. But anyways, so let's go ahead and convert these repetitive pieces of code into a class template, because again, we don't like, you know, our boss wants us to do this for like 20 different data types, and that's a lot of copy pasting. And we know that later on tomorrow, he's gonna be like, hey, I want you to add a second variable in that class. So now you gotta copy paste 20 more times and prone to errors and other lovely things. So because of that, we are smart and we are gonna make it templated from the first place. Like such. And so now, that's it. We got our template. We can go ahead and replace t with int, or int with t per se. Like that. And yeah, that's pretty much it. We got ourselves a templated class. And yet again, just like with function templates, this needs to be resolved at compile time. And by that I mean that it needs to know that this is valid code, right? It needs to know that this class template is valid when you're trying to run the code. And so because of that, you have to do a little bit of extra work when you're declaring an object of a templated class versus a regular class. Whereas before, you know, for A2, for example, I can make an object by doing that because it's not a templated class and it works just fine. However, for a templated class, you can't get away by doing this. And the reason why is because if I was to do this line of code, I am saying to create an object of class A, but I'm not telling it what this template should resolve to. And so at compile time, when it's trying to figure out if that's okay or not, it's basically not gonna go because it's like, I need to know what it is. And so it says missing template arguments for A. What that requires is for you to put the less than and greater than sign like that, and then to put the type here of what you want the template to resolve to. So if you want to make a class where the template is going to be an integer, you do that. If you want to make a class where the template is going to be a double, you can go ahead and do that. If you want to make a template where the thing is a string, then you can go ahead and do that. But for all of them, you need to tell the compiler what you intend this template class to be. Suppose that you had a class where you were doing, per se, 2 templates. So you could do something like template class U, class V, and then if you have your class, which is just called B, and let's just leave it like that for now, even if you don't use a template. If we want to create a class of an object of that B class, then you have to give it the 2 types here, which they could be the same type, by the way. They don't have to be different. It just gives you the option of being different. They're going to be used in different things. Because I mean, I might have like a UA and a VV or something. Well, that's weird. VV. Okay. That just bothers me in general. Let's just call them something else, X and Y. Okay. All right. 2 or more data type declarations of a line 35. Oh, I forgot to put the name of the thing, so we'll call it B. Do we have a B already? We have one already. So we're gonna make this one be a Z. Just to keep with variable naming conventions. So conflicting declaration of cons. Oh, okay. Geez, it's so hard. It's such a struggle to come up with original variable names in live lectures. I like using A, B, and X, and Y. I know the struggle is real, guys. But we get to it together. Wow, you redeemed a lot of extra credit at the same time. Impressive. So, yes, make sure you email me about that, so that you get the points. So, okay. We can see that this compiled, so therefore it is working for the most part. We don't really see a lot into it because we're not calling set or get, but essentially this is how you do it. And this is exactly why when you were doing vectors, they were written the way they are, because vectors are a templated class. And because of that, when you create an object or when you create a vector, then you need to tell it the type of the vector. And that's literally the syntax. In fact, you could make a fake vector class right now. I'm not gonna go and do all the pieces of it, but just so you get an idea. So as long as I don't include the vector library, this should compile without complaining about the type name variables. And then you can say template class, I guess we'll call the vector, we'll say the type of the vector. Here, we'll use type name here, since it's okay too. And then that vector is basically going to be a pointer. That's going to be holding the array of that. And then we might want a constructor to this vector class that dynamically allocates such an array. Let's just start with size of 10. Why not? So we should do r gets new type 10. And then we need a constructor for it, so the allocate. By the way, something I read in C++20, you can have multiple destructors. The reason for that is a little bit complicated, but the way you do it is you have to use a special keyword that's just called requires here. However, that keyword only is available in C++20, which I don't think I have installed here because it hasn't even come out yet. There's only, I think GCC is the only one who has created a compiler that mostly has all of the selected features for 20, but I definitely don't have the latest version here. So I don't even, I mean, I hope I have 17. I think I have tried compiling with 17 before, but yeah, I have 17, but yeah, so just a cool thing, you know. You can probably Google that and watch a video on an example with that, but you know, there are a lot of weird and cool things being added into the language. So yeah, but anyways, so now if somebody ever asks you in a test, you know, because before I could have been like, I could have asked you in a test like, can you have more than one destructor? And the answer would have been no. But now the answer is actually yes if you're using C++20. So yeah, you know, that sucks if that was a question in the test, you know, because now it's arguable. So never say never. So okay, we create a little fake vector class, and if we wanted to create an object of it, we would say something like vector int v, and then let's just go ahead and make everything public. In fact, I don't get why that would have complained about the constructor being private, actually, but now it won't, so we're okay. We can say something like v2 gets 10. No match for operator. Oh, we would have to overload this. Oh, we'd have to overload the array access to make it work in the same syntax as the vector would. So for now, we're just gonna do it like that. Okay. So there you go. Okay. So that is an example of a class template. However, unlike function templates, things can get a little more confusing with class templates when you go ahead and do things like inheritance and those kinds of things. So now let me go ahead and, first of all, let me show you how you can initialize a function outside the class with a template, because it's not as easy. So like, let's say that we actually want to define this function, this getX function here up here. This was a template one. Let's say that we actually want to define that outside the class. Okay. It's not as easy as just doing it the way you did it before. So like t and then a : get x, return x. If you just do that, it complains. It says t does not name a type, and that's true. T does not name a type actually yet. So if you want to do this, you actually have to put the word template here and the class, and then put the t. And actually, do they have to match? I don't even think they have to match. You could make this be like a u here. X will not declare in the scope. Yeah. This gets even messier. So here, actually, you gotta put in a the type of the template. So you gotta put in, I think u as well in there. There we go. Yeah. Okay. So as you can see, even just defining a function outside the class makes things trickier. No, it will. It really does if you really do intend. And also it makes it flexible. So like once you create this nasty code one time, you know, you make a data structure like a queue or something, and it's set up, then you know, you never have to ever touch it again. So yeah. By the way, all of the STL stuff, I mean vectors as an example, all of that stuff is written with templates, like literally template land. So it's so the standard nowadays. In fact, you'd be hard pressed to find something that's not templated that is supposed to be meant to be used as part of a library. So yeah, that's the unfortunate future. Yeah, so here we're writing because this class needs to be defined of a type. We define that type by using another template so that it can basically work out. Oh yeah, no, but I mean, it's better to do it outside anyways, because you can put this in a different file than this one. So you know, yeah, your implementation file and your header file. So yeah. If this was a class like this one, you know, so let's go ahead and do a function here that it's called print, which is just going to go ahead and print out the variables, assuming that there's actually a overloaded operator for them, I suppose, because that's going to be another issue if they're not built in. But whatever, we'll just say that we're calling it a built-in data type. Then this one you have to do template class. We'll use the same variables in this one. U class V, and then when you're writing the function, you would write. Let me get this right. So you do void, and then you do the class name, which is B. Then you put your less than sign, and then you put the types. So you're gonna put U and V, and you close that, and you put print. Then you put the parentheses, and you put the curly brackets, and now you can actually write your code. So cout X. And then cout Y. So you get used to it, you know. I mean, if you haven't done it in a while, like right now, you know, it's a little rusty and whatnot, but it comes back to you. Invalid declaration before print. Crap, damn it, didn't work. Where is my missing code? Oh, I forgot the colons somewhere here. So almost had it. Almost had it. Or you can just do Python and not have to worry about all this crap. You know, problem solved. Can you explain the syntax for defining a function outside of a template class again? Let me go ahead and do that on paper. That might make it easier to follow. So if you got a function inside of, if you got a template function that you're trying to define outside the class, the syntax for it is going to be start out with writing template, and then doing your class thing here, or type name, whichever one you're using. I'm going to use class because it's less letters to type. And then put in some variable name there. And the number of parameters here is going to be matching the number of parameters that you had when you created the class. So like if you have a class that only requires one template, you know, it's a template class that only has one generic type, one templated parameter, then you only put one there. But if the class has two of them, like it did on the second example that I did here, then you're gonna need to put two there. So put the same amount, okay? Put the same amount. And then close this. And now comes in the part to write your function name and whatnot. So first you're gonna put the return type, just like with any function. So the return type could be a template itself, but it could also just be something like void and whatnot. So we'll just put in void for that. From there, you normally would write, if it was a non-templated function, you know, you would do something like void a : and then you say like print, right? That would be the non-templated version of that. So non-templated. The difference is going to be that you're going to have to put in between the colons, which is the scope resolution operator, and the class name, which is that. So that's the class name, and this is the scope resolution operator. In between those things, so right here, you're gonna have to put in the templates there. So I guess since we're doing the syntax, I'm gonna write the word class name. In fact, I'm gonna put return type, and then class name, and then the T from here, and then scope res operator, and then the function name, and then your parameter list. So there you go. If you were taking a compiler's class, that's the kind of thing that they tell you to put like that. Okay, so that the parser could work. So you need a return type, then the class name, then the less than sign, the template variable there. There might be multiples. Let me show you the example with multiples, just so we have one example of that. So let's say that there's one that has like 3 of them. In that case, you would have X, Y, Z, like that. Okay? So I suppose the generalized version of this would be to use the following name, which I think it's in the book. It's called Parameterized Types, I think. Yeah, Parameterized Types. Let me write that keyword. So let me add some space down here. So template parameters are called parameterized types. And those are basically class templates are called parameterized types because based on the parameter type, a specific class is generated. So then basically that's what you're putting in here. Parameterized types. Okay, so that is going to be your example of that. Indeed, C++ got you down. Use Python. That even rhymes. With a semicolon after the curly bracket. No, because this is just a function that you're doing. This is just a function you're defining that is part of a class. So we're assuming that we have a class, you know, that is something like well, we already have one up here, so we're assuming that we have a templated class like this here, okay? And we're trying to define this function here. In fact, here, let's go ahead and do that with that function because we have one there. So let's just throw that in there. Why not? So if this is our function, if this is our class, let me shrink it a little bit. Then down here, we would write outside the class, we'd say template class T, and then T is a return type. So following our syntax here, we said return type, class name, blah, 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 blah. So class name is called A. Then we put T in there, scope res operators, foo, and then T, ampersand, G, and now we can put the body of the function, like such. Okay, and now let me just make everything bigger back again. Like that. Okay, cool, nice. So I'd say syntactically, this is the most complicated thing we'll see, you know, where it's tricky, especially when you get to inheritance and other things, because it just becomes a mess, actually. But you learn to adapt, just adapt. Let's see. Let me look at the book and see what other things they do show about this that I might want to cover. They show overloading operators, but no, yeah, I could show one overloading of the operator of a class. But let's go ahead and just make a new file because this is already kind of big. Make sure it still compiles and runs. It does. Okay. So we'll call this one template 2. And let's go ahead and take our we'll just scratch. Question: do you need a template declaration for every class template function definition? Yes, you do if you're doing it outside the class like I was doing. So yes, unless you're doing it inside the function, you need it. So let's go ahead and make a template for I don't know, what's a short example that's meaningful. It's kind of tricky. Oh, I know what we can do randomly. Let's make a vector, a templated vector. So suppose you want to have a class that has a vector in it that is templated. Okay, so we have template inception. That's why it might be a use example. So we're gonna say this. We're gonna call this class container. Actually, container might be a reserved keyword in this version of C++. Let me check. No, it's not. Perfect like that. Okay. What if I did it at 11? Would it be reserved? No. Okay, perfect. Okay, so we're gonna make a little container, okay? And so in that container, we are going to contain a vector. Now, normally we could say something like a vector of integers and whatnot, but we want this to be a templated container, so we can store any kind of the variables in there. So we're gonna write a template up here. We're gonna call that T for type, and so we're gonna make that be the vector, okay, like such. Because now we have the flexibility of basically this vector containing anything. You know, the world is the sky is the limit. Okay, so when it comes time to actually create an object of this container, let's actually first of all let's make we'll make everything public for now, like that, and then let's make a function that prints container out. So just call print, and what that is going to do is we are first of all we're gonna make it void, and we're gonna define it outside the class, so you can see practice a little bit doing this thing since it's tricky if you've never done it before. But even if you have, if you forgot, like me for a minute, it can take a time to come back. So again, we have return type, then we have the class name, container, then we gotta put in the parameter. Yeah, this is a good example. I like this. And then we put in the name of the function. And then we are going to put a for loop, and I is equal to 0, I is less than the vector. So a dot size I plus plus. Actually, because it's a vector, this is a nice little chance to practice or for loops, right? Or range based for loops. So yeah, let's go ahead and do that. So but here's the thing. Yeah. Oh, this is good. Yeah, because remember, I mean, I could use could I get away with using auto here with a template? I'll find out. Because here's the thing. Let's pick a better name for this than this. We'll say this, we'll call it data. With the ranger's for loop, you know, I would have to put in here the type. And the type is dependent upon what type the template is, right? So ideally, I can use the T here. But let's see if it actually lets me get away with using the keyword auto, or if it's going to force me to use the T there. Oh, I need a variable name. So we'll call this I for iterator. Expected primary expression. Oh, well, yeah, I need a body in here of this function. So we're going to say cout I. Space there, and then maybe a line feed at the end. Are we missing curly brackets somewhere? Oh, yeah, we are. Semicolon, actually, but still. Yay, so it actually does let me do it with an auto. Or at least it seems to be so. Yes, but, you know, otherwise, this would have to be a T, okay? But since it lets us use auto, it's a nice chance to use auto, so why not? Okay, again, auto is like the lazy man's variable declaration. So, yeah, okay. So now that we've created a little container, we have a function that is supposed to print what's in the container. I think we need to do a constructor to insert something into our container. And that's going to be good because I can show you a templated constructor, okay? So let's go ahead and do that. So the container is going to pass a parameter of the same type as the template. And so, now my question is, how am I going to insert things into this? Because if it's not a number, I can't just use the number. I guess we'll just insert a bunch of the same thing in it. How about that for now? Okay. Well, I mean, let's go ahead and still give it a chance to have a container as default. By the way, does this work in this version? Because I was looking at that in C++ 20. Does that work for a default constructor? Yes, it works. That's cool. So yeah, that's a default. You got your default constructor in there, but also we're gonna have a non-default constructor that takes a specific parameter. Now I could have used a t equals 0 or whatever, but then again, we don't know what the default is because it's going to depend upon the type the actual template class is. So you can see this is getting really interesting actually. So we're gonna call this just bar, okay? And we're actually gonna define this inside the class so we can practice doing that. So to define a template inside the class, you're gonna need to put your template class t, and then here there's no return type for the template. So for the constructor, I mean, so you're gonna put in container there, colon container, and I think you put it in front of this one. You put the t there, and then here we could put t bar. I actually don't need to say the word bar here, so let's get rid of it. So yeah, okay. And so what I'm gonna do is I'm just gonna have a little for loop that runs like 10 times. As in 10, maybe just 5, so it's not so big. And then I'm just going to push back to the template. Essentially, I don't need these for loop. Just a bunch of the same number or the same whatever this is, because it's not, might not be a number. It could be a string. It could be objects themselves. It could be, well, hopefully it's not the class within the class, which I don't think I can get away with doing, but we'll try because why not? But for now, we're gonna do data.pushback bar. So we're just inserting 5 of the same thing, okay? Because I don't know what else to insert in here. Because I don't really have, we haven't figured out a purpose of this class yet. So yeah, okay. So what else are we gonna do? Do we need a destructor for this class? Not really, because we don't have any dynamic allocation. So we'll just, I think this is good enough. So now, let's check if it compiles. It compiles, but let's actually try to make an object of this class. So container, and let's make one that's dynamic and one that's static. So container C, and then a dynamic one will be container, we'll call it PTRC or CPTR. However, neither of these lines work as they are because we need to specify the type. So let's make a container of integers because it's a good starter, and then we can make one that's something else later on. But let's see if this will compile like this. It did, actually. Great, cool. So then let's try to call print on this and see if it works. It does not work because we use a default constructor. That's why. But let's go ahead and not use a default constructor. Let's go ahead and throw in a 3 in there. So now that will use a non-default constructor. And there we go. Now we see 3, 3, 3, 3. Let's do that with the dynamic allocation this time around. So this time let's do for the dynamic one, let's do a strings. I should include the string class. Even though it's kind of okay and relaxed about that, the correct thing would be to include it. So let's be correct and proper about that. So new container. And here we'll say hello. Expected type specific before container. What does that error mean? Container string new. I think maybe I gotta put in here string again. Yeah, okay. So let me call print just so you can see that. So cptr print. So this is good that we did the dynamic allocation because I forgot about talking about that. Oh, that took a while to run actually. When you do that, when you're doing dynamic allocation with the templated class, you're making a pointer which is templated, but also when you're doing dynamic allocation, you need to put in the type of the template there as well. Okay, so yes, don't forget that, otherwise it will not compile. So the syntax for dynamic allocation is new, the type of the name of the class, the container, the template type, whatever you want it to resolve to, and then your parameters. Okay, so yes. And yeah, it works. However, I'm trying to do template inception here, but it's really hard. Let's make a vector of these things. So let's go ahead and make a vector of containers now, okay? So we are going to make a vector of objects of container type. So then here, because it's a vector of containers, we would have to write container here. However, if I just try to do this, it will not compile. It will tell me that it needs a type. Yes, perfect. So now it says type value mismatch at argument 1 in template parameter list v. Expected a type got container. You know, it's like, mom, I want this at home. What we have at home kind of meme. So really here, you need to put other lesson types and then specify what the container is of. Oh, yeah. Sorry. So let me revert to what I said. So we want to make a vector of these containers. So it's like making an array of them, okay? So if we just say vector and then we say, what is the type of the vector? Well, it's a container. It won't work because the compiler needs to know what the container is, what the type of the container is. So now you got template inception here, because the container needs to be specified what it will contain. So if we want to contain doubles in there, we actually have this nested thing here. And if it makes you feel better, we can put a space between this so it looks nicer. Okay? But that's essentially what is happening. And now it'll compile. Otherwise, it gives you the error saying type value mismatch, expected a type, got container. Okay? So this looks scary. Okay? Especially if you take away the spaces. You are like, oh my god, is that the cout operator? Or I'm sorry, is it the stream extraction operator or insertion or what? So yes, vector inception indeed. Which you can go further as well. But yeah, so now, how does this work? Well, we can push back the two containers that we previously made into this by saying v.pushback C, which is one of them. And then the other one was cptr. So that one is a pointer though. So to put dereference it, yeah, like that. Okay. And I think that will be okay for both of those. I guess not. No matching function call to push back. It's this container, why not? Maybe we need to put in here. No matching function call to vector container pushback int ampersand. I'm going to guess that it's having a hard time because it's templated. I don't think this will help, but let's try it anyways. Do you need to put the size? No, because it's not the size. That's just a constructor. Let's check Google to the rescue. Vectors, using vectors to store templated classes. C++ vector of templated class. The reason why this is not possible in C++, but possible in Java, is because C++ vector, the SL container, contains all logic instantiation sequentially packed. So I don't think it's actually possible to do. We can't push a vector in there. That's sad. You have to cast it. No, because this vector is storing objects of the class container, of the type container, and those objects are templated, and so it seems to be having a hard time because it's templated in storing that. It appears that it's not actually possible to do. Before C++ 17, you can create a polymorphic class. I think if I make it out of pointers, I could get away with it. So, okay, let's go ahead. First of all, let's try to compile this with 11. We are compiling with 11, but if we don't compile with 11, then, or sorry, not with 17, but with 11. Yeah, we still get there. Okay, so I'm going to show you a way around this that I can think of. Instead of making this of containers, we're going to make them of container pointers. And I think that we might get away with. So container pointers like that. And so now this one will pass the address off, and this one will pass CPTR. So let's see. Template argument 1 is invalid. Now it ain't. Am I making a pointer of this container type? Oh, it wasn't. No, but that's okay. Oh, I see what you guys are saying. I see. Yeah. That could be one of the reasons. Okay, yeah, okay, good point. Although I still think we're gonna get the same problem, but let's try it because maybe it'll fix it. We'll see. I see what you guys are saying. So this has to be an integer, and then we're trying to push something that was not an integer, which would cause problems indeed. So yeah, and then maybe let's make another container here. Let's make one on the fly. But first, let's just try and see if that will run. Okay. Oh, it works now. So yeah, that was the problem then. Great. So good catch. Very well done. Yes. Well done. Well done. Well done. I was starting to lose faith in C++ for a minute there. Let's go ahead and push back something else that is an integer. So this will not work, but let's just make another pointer here. Container int pointer. You know, what I was going to try to do to solve this is to make pointers instead of variables, because then the pointers could all be probably the same size, and then kind of see if we can get around that. So I kind of want to go back and try that in a second later, but still, this is a good solution to this. Well done indeed. So this one we'll call C2. Trying to remember what I'm trying to do here. Okay, yeah, I was trying to do an integer pointer like this. So C2 gets new container integers 5s. By the way, you should get an error if you try to dynamically allocate, say, doubles here. But I want to triple check that because you might not. It might just give you extra space that you're not using. Okay, cool. So it does give you an error. Nice, nice, nice. Probably with malloc. Actually, I don't know with malloc. You don't want to use malloc with templated classes. That just sounds scary. But okay, so now let's try to push back that. Okay, so that works as well. Yay! Yeah, good job, Desco, indeed. And also Josh as well. All of you guys that were saying the same type. I did not notice that. I wasn't thinking. But yeah, so now this, you know, if we want to see if this works, we can do 0. Well, that's gonna complain because it's not overloaded. But we can call print. Yeah, we can do that. So I don't have to overload it. And hopefully we see 0, 3, 3, and 5, 5 print out. There we go. So there you go. And so now, the solution that I was looking for to see if it would work was, can I make an array? Can I make a vector of pointers of the container type? So same thing I have here, but pointers. And so I was trying to put that, but it wouldn't compile, and I was curious as to the why. Template argument 1 is invalid. I know that I can make those integer pointers, but that's not necessarily what I'm trying to do, because I'm trying to make the vector be made up of pointers itself. Maybe I need to put that afterwards. Yeah, you do, because you see it's afterwards here too. Okay? Now, Mike, what I'm curious about is, can I get away? I know that I can do this. VPTR push back, for example, C2, because that's an address, and I know that'll work because I can do something like this here. Hold on, let me space this out. BPTR print. BPTR, not B. It lags when I'm compiling it. It actually takes time to compile. That's scary. So that worked with that. And if I want to do the other one, I can use the address of operator for it. So I can do something like BPTR push back C address off like that. And then I can do BPTR1 print. And that should print out 3. The question is, I don't think this should let me do it, but I want to try it, is can I add here something that is not of integer type? So like, can I push back my string one? So CPTR. That's a string container that I'm trying to push into an int container, but it's pointers. So maybe it doesn't look. No, it looked. I would have to probably use reinterpret cast to do it. I would have to do something like reinterpret cast CPTR would have to become a container int pointer to get to compile. And this is bad at this point. Did I mismatch my stuff here? Push back. Oh, I need one more closing parentheses. Yeah, so that will work, but that's bad because now, actually, it might work, but it might also crash. BPTR2 print. I don't know who there. I didn't make the function virtual, so I think it's gonna get confused. So that's funny. So it's printing out the string. It's interpreting the string as an integer, and it's printing out whatever is in that vector, which is a bunch of hellos, which it's interpreting as some scary looking code, which I'm guessing is like, and it varies, which I'm guessing are addresses inside of it. So yeah, if I put the word virtual in front of this though, makes me wonder what's gonna happen now. Oh, look at that. Oh, that's cool. I got to say hello now. So so this was what I was trying to do to solve the problem before I figured out that I was just being dumb. But yeah, so with virtuals, I have a vector of pointers of integer type. So the vectors is of container type, but they're integer containers, right? Because that's integer. But using reinterpret cast, I was able to store in there to have one of the pointers point to an object of a container that is actually a string. However, when I called print because it was virtual, it actually figured out that I was dumb and I accidentally stored a string inside of where only integers go, and it actually called the hello function. So there you go. Cool uses of virtuals. Don't do this though. You know, reinterpret cast part, that's not a good mojo. So still, you know, this would have been the dumb way of solving the problem that we just fixed by actually using the word int here instead of double. So, you know, kind of cool. Here, just for fun, let's make one for let's make one that has doubles in it inside the same thing here. Okay, and that'll be the last thing we do, and then we can call it a day on templates. So this one we're gonna make a double. So we're gonna say new container double 4.5. Do I have the right number of parentheses in there? I think I'm okay. You know, if I told you day one you'd be doing this line of code in the class, you might have dropped. So that's why you don't get told that, right? Because now you're like, oh, that's easy. But before you would have been like, oh my God, what is this? And there you go. Now it works also with doubles. Even though this thing is of integers, it's, you know, reinterpret cast. That's the YOLO cast. And here I'm just doing I'm doing the allocation of this. Instead of, you know, here I do it here and then I just insert CPTR. Here I'm doing it on the fly. So yeah. Okay, so that's templates for you. And you have an assignment on templates, but I think it's actually one of the easier ones because it's kind of like the allocation with PathMe assignment, where it's just a tutorial-ish assignment. You know, it tells you to do one line of code and just basically the same. I think I say that the exact number of comments is the exact number of lines that you have in your solution. I do want to warn you that when you throw an inheritance into the mix, things get pretty interestingly messy. So that's not all there is to templates. That's all there is to this level of templates in this class, but there's a lot more to it, which is up to you to figure out. Because, I mean, Yeah, you use templates a little bit in 302, but you don't really use them inside of the classes at UNLV. So it's really up to you to actually take the prerogative if you're a CS person, a CS major, and learn other programming techniques that are not covered in class, which are tons of them. In fact, what you learn in 202 and 135 is basically the equivalent of like the most basic version of programming without taking advantage of any of the things that have been introduced in the last, like, I'd say probably 10 years. I mean, we just compiled this line of code without even using the 11 flag. Actually, we did use it, but because of vectors, right? So, okay, vectors aside, actually vectors I think were added in, were they added in 11 or 03? No, 11. Okay, so I guess we have 11, but see, that's the thing. In 11, not in 13, not in 14, not in 17, and not in the one that's going to come out, which is 20, but 11. That's still 10 years old almost, right? And if we're not using vectors, then you're learning stuff that is 20 years old. So essentially, there's a lot more to C++ than you've learned in 135 and 202, as you can guess. But that's okay, because at this point, you have enough knowledge that you can basically go and learn the rest of the language on your own. And that's kind of the way it's going to be, because if you look at the syllabus, this is literally the last thing that we're covering in this class in terms of programming. The remainder of the class, starting from in 5 minutes from now, I suppose, is going to be learning about concepts like recursion, which is just a programming, a way of approaching a problem and solving it. And then we're going to talk about data structures like linked list, and then we have time, stack, and queues. And then in 302, you are going to be talking about other data structures. But while they might teach you some like nit and picks things, in those level of classes, you're pretty much done at this point. You have learned C++ at least at the introductory to intermediary level, somewhere in between that. And you can code whatever you want at this point. What you learn from now on for C++, if you learn on your own time, is more of meant to sort of allow you to code in less line of codes and faster, which is an example of that is templates. You don't need templates to code anything in C++. It just makes your life easier if you just make a templated class that you're working with, and then once you have it done and it's good to go, you can use it for all these data types and so on, right? Operator overloading is the same thing. You set that up once and then you're good to go. But you don't need it to write anything in your code. You could write, you could write a Call of Duty Warzone, or you could write Facebook without knowing templates or operator overloading. But they're tools that are going to make your life easier. And like these tools, there are a lot more out there that we don't cover. And it's kind of going to be your job at this point to learn them if you're really serious about programming, so that you can actually become a good programmer that is not just can get the job done, but can get a job done in an elegant way and quicker. Because at the end of the day, people are paying you to code not by line, that's the stereotype, but actually by task. So if it takes you 10 days to do something very basic, then you're gonna get fired probably. So you need to be able to code fast, good, and safe. So with that said, congratulations. You learned at least the programming part of the class. And now we're going to switch gears and start getting a little bit more beyond programming into other concepts like data structures and recursion. And for the rest of the, when you get to 302, that's all about data structures. And then you get to classes in the CS department, there's no programming at all, because computer science is more than programming. Programming is just a tiny piece of the world of computer science, but it's the one that actually you typically find a job in if you're a software developer or software engineer. So just wanted to give you that sort of congratulatory but message, but also warning that this might be the end of the UNLV's programming area of the CS degree, but it's not the end of your quest for knowledge, because you should still go out there and learn more than what has been shown here, And there's a lot of things out there, especially other languages as well, because some classes may be taught in C# or actually C# would only be 1 or 2 classes, but they might have a couple of classes that are taught in Java, like the 326 and compilers class. But outside of that, they're not really going to do other languages. Maybe Python if you get lucky, depending on if you take like databases. Well, SQL for databases, I suppose. But yeah, you're not going to learn R. You're not going to learn, unless you take the machine learning classes, you might learn MATLAB, or Python in that class. But yeah, it's your prerogative at this point to take these knowledge of these things and apply them to other languages so that you can learn those quicker. So, yep, that's pretty much that discussion. So, this might be the end of the class, but it's not the end of your quest for knowledge if you want to be a good programmer. With that said, let's talk about something that will make you a better programmer. And it's not related to coding. So at this point, I can probably just close the IDE. Although when I do linked lists, I am going to code them for you. But you know, when you get to 302, they're going to tell you do this thing, and they're not going to tell you. They're not going to hold your hand. They're just going to be like, do it, and then it's your job to actually take your programming skills and actually do it. So make sure you practice programming if you're not taking 302 in the fall, so that you don't forget these things. So recursion. This is a hard topic for people that are new to it, actually. I'll do my best to try and teach it to you, but you are probably gonna have to go and read the book on your own or go online and just see examples of this, because it's really tricky. People that learn differently, and recursion is one of those things that you either get it or you don't, and if you don't, then something else you'll see online will just click with you, and then you'll get it, you know? Hopefully you do get it at some point, because otherwise that's kind of bad. However, at the same time, at this level in 202, I'm going to teach you recursion, and I think you're unfortunately going to come out with the expression or with the sort of idea that it's kind of useless or annoyingly hard. However, that sort of mentality will be removed from you when you get to 302, and we talk more about data structures and specific algorithms that are just way, way easier to implement recursively, like quicksort, than iteratively. Quicksort is one of the sorting algorithms. And so the process of solving a problem by reducing it to smaller versions of itself is called recursion. And that's just right off the book. So let's go ahead and write that down here. And there's got to be a second part of the definition, because otherwise I'm not happy with it. Because this might be like misleading in a way, actually. But let's go ahead and write it because it's in the book. The process of solving a problem by reducing it to smaller versions of itself. Okay, and so that doesn't really tell you anything, to be honest with you, but let me propose to you, and the book uses factorial, so I'm tempted to use that, but I will try and use a different example, maybe Fibonacci. There are some problems in math that require a previous solution to solve the next step. And an example of that could be Fibonacci sequence. So what is Fibonacci sequence, for those of you that don't know? Fibonacci sequence is a sequence of numbers, it's a series, I suppose, I think, where you can start with 0 or 1, depending on who you ask. Let's just say we're going to start with 0. And then there are some specific orders of numbers, and those can be, for example, the first 2 that you have to have. Those are always going to be the case. The first and second number of Fibonacci are always going to be either 0, 0 or 1, 1, depending on who you ask. Okay, we'll go with the 0, 1 example. After that, the third digit of the sequence is going to be the previous 2 digits added together. So if you want to know what goes here, you're going to take 0 plus 1 and you're going to put it there. So that's going to be a 1. So the third number in this sequence of Fibonacci is going to be 1. Fibonacci. I think it's spelled like that. There might be two N's. Let me quickly Google that so we don't offend the man. Fibonacci with two C's. Yeah, okay. So that's actually good like that. Okay? So Fibonacci basically says that the first and second, or first number is 0, and second number is 1, and third number and thereafter is previous number plus second previous number. So like the second, so the second to last number, okay? What that means is that if we want to compute the next digit here now, the fourth digit, we're going to take the last two digits and add them together. So we take 1 and 1, which gives us a 2. Then if we want to compute the number after that, we take these two numbers and we add them together and get a 3. Okay? Now we want to get the next number, we add the last two. So 2 plus 3 is 5. And then 8. And then 13. And then sorry, it's a long, like 21. And then 21 plus, so what is 8 plus 13, 21, and then 13 plus 21 is going to be 34, and so on. Okay? What if I told you to write a program that can compute the nth Fibonacci sequence number? The nth number in the Fibonacci sequence. And by that I'm saying, for example, we're going to say this is the 0th number, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? So what if I wanted to compute the 10th? However, you don't have anything. All you have is the rules that say here, the first one and the second one is 0, 1. So all you have is this, and you got to compute the 10th one. Can you write a program to do that with your current knowledge? The answer is yes, you can, but it's a little tricky to write, because one of the ways that you can do it is you could run a for loop, that runs 10 times, and then you can keep sort of the ongoing count, right? So you could do something like for int I is equal to 0, I is less than 10, since you're trying to compute the 10th number, I plus plus. Although actually, I would start the count maybe at 2, because you already computed the first two digits, which are going to be 0 and 1, right? So we're going to call them, let's say previous and second previous. So that's a 2 there. And then this is 0 and this is 1. So now to compute the next digit, which we'll call cur. Well, no, we can use the same variables here. So yeah, we'll store it into previous and we'll shift them down. So to compute that, let's make it temporary for now. So we'll say int temp is going to equal previous plus previous 2. And then to prepare ourselves for the next answer, we are going to store into previous 2 what is currently in previous, and then we're going to store into previous what is currently in temp. And that should basically prepare us so that the next time that we run, we will basically be adding it. So if you're going to see what happens here we do 0 plus 1, and then this stores a 1, and then now we update. So let's put little boxes to represent what is contained in the 3 variables. So this is previous 2, and this is temp. Okay? So right now, previous has a 0, this is a 1, and temp has nothing because it's not initialized. But then we run this line of code. So we'll say this is line 5, line 6, and line 7. Actually, I don't know if that's actually going to count right, but whatever. So when we do line 5, this will store a 1. Okay? And then when we say previous 2 gets previous, that is with line 6, we are going to update. Hold on. The way I set this up, then I would want these to be backwards, like that. Okay. So yeah, because otherwise this thing is. I mean, it actually would work, but the series will be off by in a way. So yeah. Okay. So now let's run that again. So this temp will still have a 1 in it, but then when I run previous 2 gets previous, we're updating this to have a 1 now. So now both of these have a 1 in them. They all have a 1 actually, but after we finish running everything. But then when we run the second time around, the second iteration of the loop, then temp is going to have a 2, which is the next number in the sequence. And then we're going to update previous 2 to have the value of previous 1, which is still a 1. But then previous is going to update it with temp, which is 2. And then if we run it again, then temp is going to have 2 plus 1, which is 3. Then previous 2 is going to get updated with previous 1. So this is going to get a 2 in it. And then previous is going to get temp, which is 3. Okay? And so on. Okay? And this is one way of solving this problem. Eventually, when this for loop finishes, I expect to have in previous my answer. You won't see it in temp because that's a local variable, but you would in previous. And I might be off in the for loop by 1. I might have to do one more iteration. I don't know. The way that I set this up, I think it's okay, but we can test it really fast by running the code. Yes. Well, hey, after next week, I'm not going to be streaming. Hey, greetings from Argentina. Oh, hello, Argentina. Hope you guys are doing safe over there. So, okay, let's go ahead and write this code really fast since we're just about to finish. Actually, we're going to do 1 and 0 here since this is what we wrote on paper. And then this is going to be previous plus previous 2. And then we said previous 2 gets previous. And then we said previous gets temp. Okay, so that's what we wrote on paper. So let's see if we're off by 1, which we might be. But we'll fix that. Okay? So now let's change directories since we made a new directory. Let's go ahead and compile this, and let's run it. And we get 89. So, yes. So what did we do? We didn't just compute the sequence. We actually we screwed up the addition at some point. We went a little bit too far there. So let's go ahead and pull back down to a 9, or actually probably even an 8. Oh no! I see the issue that we had. I put a 0 here. Yeah. So I did way too many Fibonacci digits. But there we go. Okay, so thank you. Good catch. So yes, if we saw it at 2, then so we actually had it right. We were not off by anything at all. That's exactly what we had here. But that problem solving of doing this is a little bit tricky, right? With this for loop situation, to make sure we don't get it wrong. Okay, and so this is one way of solving this problem. Recursion, however, is a different way of solving this problem that might make more sense from the sort of problem-solving approach. Because if we look at the rule set here, it says that the first and second digit are 0 or 1, and then the third one is based on the previous two. So what I can do is I can turn this into a function and then call the function upon itself to basically solve the smaller problem, which is one digit before us, until we get to the base cases. So I know that's a little bit too much for now, but since it is the end of the time allotted, then I'm going to go ahead and stop here, and then I'll pick up from here tomorrow, and then we'll really talk about recursion, because I guess we haven't yet really shown you anything recursive here. But you know, remember this example because we will pick up from this tomorrow. Okay? So and try to read the book, at least the first page of recursion, so that you can get a feel for it. Okay? So any questions, however, at this time? With the count for memory addresses in assignment 6, do you want them for all of the volts or only just for volts 4 and 5? Only for the ones that I asked you to do it on. As somebody was asking on Discord, there isn't a specifically defined what? There isn't a wow, you're toxic. There isn't a defined output in this example for the program, so you have a flexibility to not necessarily see out everything in the basically you want the TA to see that you solved the problem and that you were doing the right thing. So basically see out whatever you want, and you don't need to see out for any other vault than 4 and 5 the addresses. So she is being toxic. Crazy dog. So yeah. So any other questions? Output sample. Yeah, so there isn't an output sample. So again, you have a flexibility in that. The way that you're gonna get graded on is if when debug mode is off, you can still crack all the vaults and get access. And if you have that little print statement that says access granted or whatever, that's how you're gonna get your points. But in addition to that, the TA would like to see to make sure that you actually did the thing right. So see out your steps in a little bit and show a little bit of your thought process to make the TA's life easier, to make sure everything is good. But that's the main requirement, that you see the access granted. And the TA is going to check that you don't just hard code that or something. You know, he wants to see that actually you do get the access granted. So, yep, that's the answer to that. So suppose I will, I'll get rid of this thing from here, since it's not really what we covered today. We mostly did templates today. So yeah. Anything else? Any other questions before we go? You're welcome. All right then, sounds good. In that case, I will see you guys tomorrow at 5 p.m. How do I increment int again? How do I increment int? What do you mean increment int? Oh, an address? Just +1 or ++. That will do pointer arithmetic and increment. So if you have one integer and you want to go to the next one, you just do +1. Yeah, you increment the addresses the same way that you would increment a counter. You just do +1. Well, assuming that that's an address. So if you have if you got yourself a pointer of integer type and you do ptr ++, that's going to increment it by 4 bytes or whatever the size of your integer is. You can also do something like ptr equals ptr +1, and that's going to do the same thing. So yes, and if it, you don't need the address of operator if you're dealing with a pointer. If you're not dealing with a pointer but you still want to increment it, so like let's say you have a variable b and you have a variable c beneath it, and you have the address of B but not of C because this is private or something, then you can use your PTR, assign it to B like that, and then do PTR plus plus. And now this should point to C at this point. Alternatively, if you really want to be doing this in one line, which I wouldn't recommend, is you could do something like that, I suppose, as well. So, yep, that's the quick and dirty solution to your question. So, all right then. Take care, guys, and see you tomorrow at 5 p.m. Apologies for my dog being a little toxic.